All right, we'll go ahead and get started here. Hello everyone, thank you for coming to Conspiracy 2023. My name is Levi. I am a team lead analyst intern at the CSSCD. I just got my Security Plus certification, exciting stuff. And today I just want to go deep in on the mechanics of remote code execution. I know this is silly, being a cybersecurity person, I love the ideas behind attacks. I love going into them, seeing what they mean. And remote code execution is a very vague term. It means a lot of things. But hopefully I'll take you through it. Hopefully I'll explain some stuff, make it make more sense. So let's start off by painting a picture. Let's say you're playing Dark Souls. Now how many people heard of Dark Souls? Got a couple people? How many people love Dark Souls? Less hands, less hands. Dark Souls is a very interesting game, and I'll catch people up. It's known for being notoriously difficult as a game. It's one of the hardest games out there, and a lot of people swear by its challenge. And Dark Souls has an interesting mechanic called the invasion mechanic. Now I know that sounds bad. We're in cybersecurity. Invasion's a bad word, but it's a game mechanic. And the game mechanic is essentially other players can invade your game, and they can take you out, and the moment they take you out, they get treasure. It's not just any treasure, this is the best treasure in the game. We're talking good stuff. Players are incentivized to come into your world and take you out to make sure they get what they need for their playthrough. It's a really cool system, and it creates some really interesting situations where you've gotten super far, but you can't quite make it, and then another player comes to take you down. You're like, oh no, I'm done. That's it. This is done via a server process where another player sees your world through a server, connects to it via matchmaking, and then comes in to take you out. So back to this. Let's say you're on your best run so far. You've got good health, you're running up to a boss, you're very close to finishing up, and you see that invasion appear. Someone's in to take you out. They want you done. And then a Windows PowerShell window pops up. This is a perfect example of remote code execution. This is a type of cyber attack, and there's two requirements to it. They are able to execute arbitrary code, and it can be done over a distance. These are both very important, and it's kind of deceptively vague. Arbitrary is a very important word here because it means determined by chance, whim, or impulse, and not by necessity, reason, or principle. This is a definition I pulled off of Google. Not determined by necessity is the important part here. A lot of cyber attacks are defined by their limitations. The limitation, we saw in Ty's presentation earlier, there's a limitation to the window. If they don't have administrator enabled, then it's not going to be able to enable the SSH. There are always limitations to cyber attacks, and that's usually what makes them weak. If you can find the limitation, you can block it out. It gives you the ability to stop it. Arbitrary is dangerous because it does not have those limitations. So when this PowerShell window pops up and you're playing Dark Souls, that is any command that they want to execute. This is a real Dark Souls exploit. This isn't just an example I made up for the sake of it. This was an exploit discovered in 2022 with a 9.8 score out of 10. It was such a big issue that they had to take down all of the servers as soon as they could from all of their games. Not just Dark Souls 1, but 2, 3, Demon Souls, and Elden Ring. Shut them all down, and it took them 2 weeks to repair the issue. And it did permanent damage. Their Dark Souls 1 servers never went back online. If you play Dark Souls 1, the matchmaking feature is permanently disabled. You cannot play it anymore. This is how dangerous of an issue it was. Here's a list of other games affected by RCE exploits. They're very common in PC games. All of these are on the computer in some way, and they're usually predominantly PC. Team Fortress 2 and Counter-Strike, Roblox and Minecraft are all known for being on computers. And hackers were able to go multiplayer with these games, play with other people, and then execute RCE scripts to affect their computers. But it is important to draw the line and why I talked about Dark Souls instead of one of these other games. RCE still has its own severity, and Dark Souls was definitely one of the most severe. It depends on where it's at on the scale. RCE might only be able to meddle with the application. In the instance, Grand Theft Auto, there was RCE, but all you could do with it was modify the enemy player's stats. So I don't know, you got rid of their money or stuff. And that really only affects in-game. It's not that big a deal. I don't even think it got into the National Vulnerability Database like Dark Souls did. But Dark Souls, where it allowed you to access PowerShell, one of the main underlying components of anybody's Windows computer, that's much more severe. And so it's important to keep in mind When I say arbitrary, I'm only referring to the code that's input. So where the code goes isn't arbitrary. Maybe the code only goes so far as the game. So it's not that big a deal. It's important to establish where the arbitrary code is being executed. But now that we've got that out of the way, we're going to move on to how does it happen? How did the hacker get access in the first place? These are what I like to refer to as the big three, and they are dangerous. These are the three methods that a hacker would typically get in via RCE, starting with injection attack, deserialization attack, and out-of-bounds write. These are the three main methods. And Dark Souls is an out-of-bounds write, if you're curious what kind of category its RCE attack falls into. Injection attack is one of the most common. You've seen it a lot. SQL injection is a type of RCE because it's just remote code being executed on a SQL server. Usually it happens through insert boxes, but anytime you can get a user to input something, there is an opportunity for an injection attack. And you counter it with input sanitization. Please clean your inputs. It's so important. This is a good example of that. A user would normally just type in their username, password, and then the SQL server searches the tables for it, where an attacker can input certain code to check for usernames, for passwords, see if what they have is right, what they have is wrong, and potentially even drop the table if it isn't safe enough. This SQL injection is definitely the most common, but it is only one type. There are other types of injection code out there, especially for XAML databases or other kinds of languages you plan on using. Next up is deserialization attack, and this is one of the more interesting ones that you don't hear about super often. This is the idea of creating malicious objects and then running them through a computer when the computer thinks the object is safe. If we were to paint a good example, let's think of a machine that vacuum seals bags. So you take your open bag, you put whatever you need in it, and you send it through the machine, and you get it vacuum sealed, and you take it out. And then if you want to unvacuum machine it, then you just send it through the other way, and it comes out an open bag. This is essentially if a hacker was to open your vacuum sealed bag, put their own malicious code inside of it, and then vacuum seal it themselves. And that way when it runs back through the machine, the computer takes it and breaks. It's as if something it thought was safe that only contained data contained the malicious code. This happens a lot on websites. Websites will take products, they'll take commands. Hey, you're trying to buy something, you know? We need this request or this data. And then hackers will feed it data or alter the stream to contain malicious code. And as such, it gets sent through the entire thing, the machine takes it, runs the code, and kaput. This can happen with a whole bunch of things. Deserialization attacks are dangerous, and the main ways to help with it are hardening your stream so that way your computer can tell the difference between what they're supposed to be running and what they aren't, or keeping a better eye on whatever objects the hackers are putting bad information into. And finally, out-of-bounds write. And this is definitely the most complicated, but it's also it's hard to execute, it's very potent. It's very dangerous, and it's very hard to stop because of how the method of buffers work. To kind of give an example, there's a lot of numbers on here, but we don't want to worry about them too much. The idea is that this is the box where the user is supposed to input their commands. And you expect it to only be inside the box, you put more space in the box as you need it, but the user, or in this case the malicious actor, is able to overflow out of the box. They're able to go further than you meant for them to. And so whatever you expected them to type in the box, well, sure, that's fine, that's out of the way. The issue is what's outside. And the outside box contains malicious code, malicious scripts, things that your computer can run without even having to deal without even thinking it's malicious. It's almost as if the developer wrote it itself. And it's the most potent because this is one of the hardest ones to identify, and it's one of the harder ones to fix. Threat actors love RCE. It's amazing. It's wonderful. It's one of the most powerful forms of exploit because of arbitrary code. And most RCE vulnerabilities in the National Vulnerability Database are rated an 8 at a minimum, and several 9.0 and 9.8 and 10 level vulnerabilities include RCE. That's just how dangerous it is. So how does RCE affect the individual? Just your own self at your own personal computer, browsing the internet or what have you. I've been talking about arbitrary a lot, or any command they want. I've been talking about, oh, they can do anything. What does that anything include? What goes into that? Well, Here's a couple examples. Sensitive data exposure. They can see your files, anything you've saved on there, personal work documents, social security number, bank statements, anything you have virtually saved on your computer, it's open. It is the ability to see that, make use of it, identity theft, hoax, phishing, etc. And then there's crypto mining. This one is especially common with PowerShell because you can use PowerShell to install your own applications. If somebody gets access to it, they can run code to install their own PowerShell executable and then run it on your computer. They usually run it in the background, use Task Manager, make sure you don't see it, and then they funnel the profits back to their computer. Similarly, profit-oriented ransomware. Use it to encrypt your files, request that you pay a fee. That being said, this is more prominent in businesses than it is in personal computers because you can get a lot more money from businesses. They have a lot more to lose. But it is still possible for it to happen on personal computers, and it shouldn't be underestimated what can happen. And then this one's less of a personal issue, but should still be included on the list, being part of a DDoS attack. A RCE attack is a really easy way to install an executable that takes your computer's processing power and uses it towards requests for other computers. Overrun servers with requests, make sure they can't run anymore, and just outright destroy a company's ability to function. Obviously, this doesn't affect you as much as it affects the company, but it's not really great. It takes up processing power, and when the company decides to do investigations on what was happening, your IP ends up on the list of IPs that they might look at because it was part of the DDoS attack. You really don't want to deal with that. But on the other side, how can RCE affect an organization? This isn't just you anymore, this is you and a group of people, this is you and a functioning business, organization, community, etc. So many things, woo, we love it all. System penetration, privilege escalation, sensitive data exposure, denial of service, crypto mining, ransomware, and more. We love to see it. The biggest ones here are definitely system penetration, privilege escalation, and ransomware. Ransomware is huge because it's one of the fastest ways of making money off an organization, and system penetration and privilege escalation just allow you to do more ransomware, access more files, get to more endpoints, use more services, etc. It just opens up the windows more. RCE leads to all of these attacks, and they are dangerous. So, to kind of nail this all down and just like hammer it into your head, the particularly nasty RCE exploit, Log4Shell. This is a dangerous exploit. It was found in CVE, or it was found in 2021. It is listed as the most critical vulnerability of the decade at the time. I don't think anything's been found that's about as nasty as Log4Shell. It was given a base score of 10.0, and one of the main reasons is because it was massively applicable. Log4Shell targeted a program named Log4j, which was a library used in Java programs. And Java is a massive programming language. All sorts of applications use Java, and if it's a big application that uses Java, it probably uses Log4j, and then it can be exploited by Log4Shell. It took 2 weeks after discovery to fix, and it caused massive ransomware attacks and data leaks. And one of the reasons why it was so powerful is not only was the code you could execute arbitrary, where you could execute it was arbitrary. Any server, any computer running Log4j was just as vulnerable to this attack. You didn't have to worry about where you were hitting your attack or what you typed, making it extremely exponentially dangerous on the scale of attacks. So, we've gotten you thoroughly scared. All sorts of attacks. These things are terrifying. How do you stop them? And you're going to hear the advice for almost any other kind of attack: patch, patch, patch. Most RCE vulnerabilities are fixed within a couple of days. The exploits that I mentioned, the Dark Souls exploit and the Log4j, were definitely outliers. Because they're patched by the developers very quickly, as long as you've got the patch in, then you're usually safe. And patching can be a whole process on its own, so it's important to make sure you have automated patching services. An issue with this can be depreciated programs. If your program is not receiving support from developers anymore, it's not getting the RCE patches that it needs, or any other kind of attack. Keep an eye on your programs. Make sure you know that they are still getting patched and these exploits are getting fixed. And if they aren't, consider getting different programs that are being actively supported. Adding layers of security. This is a thing of like, hey, maybe the hacker did manage to make it on my Windows PowerShell, but my Windows PowerShell is protected with a password. So just because they're in doesn't mean they can affect it. This is a good way of working around it, and having those layers of security helps. Maybe your endpoint doesn't allow access to PowerShell, so the hacker's entire way of getting in is null. they can execute arbitrary code, but if they don't have the means with which to execute it, then it doesn't really work for them. These layers of security are important. Make sure you've got several barriers, so if they break through the first one, there's another one that they get stopped at. And finally, staying aware. RCE exploits are usually very well communicated the moment they happen because of how destructive they are. There's lots of news sources that would talk about these exploits and vulnerabilities, and developers will often make it very well known. Businesses will engage in threat analysis teams that would communicate this information to one another, and then you can take it, follow the indicators of compromise, follow the fixes, the patches, and then move forward with them as you're able to. Staying aware is definitely the #1 way to make sure these attacks don't hit you, because the idea is the attack should only work once. And then if you follow this advice and work through it, you can protect yourself and get back to the more important things, Dark Souls. Thank you very much. If anyone has any questions, I've got a little bit of time, I'd be happy to answer them.
Where are you from?
I'm right here from Muncie.
Okay.
I guess this is Anderson. I am from Muncie, Indiana, whole time.
Okay.
All right. Thank you very much.
What's your major, by the way?
Oh, I am a computer science major at Ball State. I'm doing concentrations in cybersecurity and concentration in data analytics.